Good morning, students. Today, I want to discuss the first unit of physical chemistry, that is solid state. Is unit number 1, solid state. Students, before I proceed the discussion on this chapter, let me recall the other states of the matter that what we learned in first year. In first year, we learned about the gaseous state in detail and few properties of physical chemistry. Now, in continuation with that, in second year, we study about the solid state. In this chapter, we study in detail about the arrangement of the particles or arrangement of the molecules, ions and atoms in a molecule, the shape of the molecules or the shape of any solid substance and the geometry of the solid substance. Okay. In detail we study about that solid state, and before that let me discuss some general characteristic properties of these solids. Let me write general So here I am explaining the properties of solids comparing with the gases and the liquids. As we know, in gases and liquids there is a small intermolecular distance is present. Okay, and the gases and the liquids, gases they does not have any shape or volume, whereas in liquids they have a definite volume but they does not have any definite shape. But in solids, they have definite shape and volume. Let me go with the second property. Okay, so why these solids are having a definite shape and volume? Okay, because so here in solids, the particles, the constituent particles that we call as the atoms, ions, or the molecules, they are strongly held with each other. Okay, so here we say that the intermolecular force of attraction between the constituent particles is very strong, whereas the intermolecular force of attraction in liquids and gases is weak. Okay. In gases it is very weak, that's why the gases they does not have any shape and volume, but in liquids they have some intermolecular force exists between the molecules, that's why they have a definite volume but they does not have a definite shape. Okay. And third stress, because of this intermolecular force of attraction, the intermolecular space present between the molecules is negligibly zero in solids. Okay. The third general property is the intermolecular space or the empty space present between the molecules is nearly zero. Okay, there is no intermolecular space between the molecules, but there is some voids are present, so that we will discuss in later. Okay, so next the fourth property here. That students, because of the intermolecular force of attraction and the intermolecular space which is zero, the solids are incompressible. Okay. Whereas the gases are highly compressible, okay, and liquids are less compressible. Okay. And then another one, fifth property is the density. Students, we define the density as mass by volume. Okay. So density depends on mass as well as on its volume occupied by the particles. Okay. See, due to the strong intermolecular force, the volume occupied by a definite atoms is very less. So that's why the denominator term is very low, so therefore the density is high. The volume occupied by the molecules in solids is very less. Okay, so therefore the density is high. And in liquids and solids, the density is low compared to the solids. Okay, so because the number of molecules occupied in a given space is more, so therefore the mass and volume changes with respect to that density is also decreases. Okay. Now friends, these are the few properties of the solids. Okay. Let me recall once again. The solids does not have any shape and volume, and solids is an intermolecular force of attraction is very strong, and in solids the intermolecular space is nearly zero, and in solids are incompressible because of the zero intermolecular space, and the density of these solids is very high comparing with the gases and the liquids. Okay. Now, with this, let me go with the next one, the classification of solids. Okay, students, so next one, now let me discuss about the classification of solids. Okay. Now, students, here, the solids are classified mainly into two types. Okay. One is the crystalline solids, another one is the amorphous solids. Now students, this classification is mainly based on the nature of the solids. And there is other types of the classification also done, that is based on the binding force present between the molecules. The solids are classified into four types. Based on its electrical properties, the solids again they are classified. Based on its magnetic property, the solids are again classified. So that we will study later, but let me go with the first one. Based on its nature, the solids are classified into two types. One is the crystalline and another one is the amorphous solids. I think you have familiar about these two types, crystalline and amorphous. In lab also we have seen the crystalline solids and amorphous solids while doing the salt analysis. We know that the crystalline solids, they are hard to touch and amorphous are smooth, whereas the crystalline solids are soluble, whereas the amorphous solids they are insoluble in water. Okay. So this is some preliminary analysis we done, or like that we differentiated by doing these preliminary analysis crystalline and amorphous solids. But now let me go with the other differences between these crystalline and amorphous solids. Here students, in the crystalline solids, the arrangement of the molecules is in a orderly. Okay. So that arrangement is in a long range arrangement. Okay. For example, if I take the sodium chloride as in a crystalline solids. In sodium chloride, okay, so there are two ions. So one is the sodium, another one is the chloride. Sodium is in a positively charged, whereas the chloride is in a negatively charged. The arrangement of the ions in this solid sodium chloride crystal is in an order. Okay, like the positive, then negative comes, then positive, then negative, then positive. Similarly, below to that positive, there is a negative, then positive, negative, positive, negative. This is the arrangement. It is in a three-dimensional arrangement of the ions in a solid sodium chloride crystal. Okay. If this arrangement is a long range arrangement, then that solids we call them a crystalline solids. They are crystalline nature. So therefore, the crystalline solids, they have a definite characteristic geometrical shape. And the arrangement is in a long range arrangement. And friends, here in amorphous solids, this arrangement is distal. Okay, it's an irregular shape, or we say that this range is in a short range arrangement. Okay. The arrangement of the ions, it is disturbed after certain distance. For example, say there is some compound like A and B. So A is in a positive, B is in a negative. So here initially there is a positive, negative, then positive, negative. After certain range, this arrangement is disturbed. Okay, so that's why it is having an irregular shape. Okay. And this arrangement we see in solids is in a only short range arrangement. And since the next one is the third difference is the crystalline solids, they are having a sharp melting point. Okay, so for solids we find the melting point of a compound. The difference here is the crystalline solids having a sharp melting point, and the amorphous solids they melt over a range of the temperature. Okay, let me clear this one. The sharp melting point means, for example, a solid of AB type, its melting point is around 345 degrees Celsius. If it is in 345 degrees Celsius, that crystalline substance, it melts exactly at a temperature of 345 degrees Celsius. That we call as a sharp melting point. Okay. Whereas the amorphous solids, if its the melting point is in a 345 means, the amorphous solid starts melting at 340, and the melting of that solid completely converted to liquids at a temperature of 350. That means it melts over a range of a temperature, not at any sharp melting point. Whereas the crystalline solids, they converted solids into liquid exactly at a temperature of 345. Whereas the amorphous solids, they melt over a range of temperature. And the reason behind for this is because of these are having a definite geometrical shape and long range arrangement. That's why they have a sharp melting point. Whereas these have irregular shape and short range arrangements, so that's why they melt over a range of temperature. And since the next property is these crystalline solids are anisotropic in nature, whereas the amorphous solids are isotropic in nature. Let me clear this word. The isotropic, iso means same, tropic means the property. There are certain properties which are having same, whereas the crystalline solids, they exhibit different properties. So here the properties means there are certain physical properties, for example, the refractive index, mechanical strength, or electrical conductivity. So when we measure these properties for a crystalline solids, they give different values when it is measured in different directions. Whereas the amorphous solids, they show a same values when they are measured in different directions. Let me clear this. Okay, for example, if we take an example as sodium chloride. So sodium chloride, the arrangement is sodium, then chloride, then sodium, chloride, chloride, sodium, chloride, sodium. This is a solid sodium chloride crystal. So these are the ions arranged in a solid sodium chloride crystal. And when we measure the refractive index, say in this direction, so it gives a different value. If I measure the refractive index in this direction, it gives a different values. Okay. It's because when we measure the refractive index in these directions, only the positive ions, that is the sodium ions, are one side and the negative ions are on another side. So when we measure the refractive index in this direction, there is a arrangement is different. There is a positive, negative, positive, negative. So that's why they show different values. Okay. So therefore we call this the crystalline solids. They are anisotropic in nature. Okay. So let me clear again. The anisotropic means the solids or the compounds which show different physical properties like the melting point, refractive index and mechanical strength and electrical conductivity. They show different values in different directions. And these amorphous solids, they are isotropic in nature. And since the next one, another property of crystalline solids is the crystalline solids, they have a definite heat of fusion. Because of sharp melting point, they have a definite heat of fusion, where the amorphous solids does not have a definite heat of fusion. That we call as a delta F of H. And whereas the delta F of H, enthalpy of fusion, is having a definite enthalpy of fusion, where the amorphous solids they does not have. Okay, the next one. The crystalline solids, they are called as true solids, whereas the amorphous solids, they are not the true solids, they are supercooled liquids, or we call as pseudo solids. Okay, so examples for this crystalline solids is you can take any crystalline solid like any salt, sodium chloride, calcium sulfate, or any metal, copper. So these are the crystalline solids. So amorphous solids, for example, rubber, glass. These are the amorphous solids. So these are the few differences between crystalline and amorphous solids. Now, students, the next type of classification of these solids. Just now we discussed the amorphous and crystalline solids. This classification is based on the nature of the compound. The next one is the classification of solids. It is based on the binding force present between the constituent particles. So here, these solids are classified into four types. So as the ionic solids. Second one is the covalent solid. Third one is the metallic solid. And fourth one is the molecular solids. Now let me discuss first these three types of the solids. Ionic solids and covalent solids and metallic solids. And students, here this is classification is purely based on the binding force present between the constituent particles. The binding force means the attractive force present between the constituent particles. So here the constituent particles, either it may be ions, atoms, or in molecules. So for this, let me go with the first point about these solids is what type of the constituent particles is present in these types of the solids. See, in ionic solids, the constituent particles are the oppositely charged ions. So here the ions are the constituent particles. Ions means, for example, the sodium chloride. Sodium chloride is a type of ionic solids, so in which the constituent particles are positive and negatively charged ions. So second point is the binding force. The binding force present between the ions. And since here in ionic solids, let me take example sodium chloride. In sodium chloride, we know the sodium is a positively charged, chloride is negative. Or this is simply, let me write the positive and negative plus this is a sodium chloride crystals. This is an orderly arrangement of the ions. So it is a solid crystalline sodium chloride. So here the constituent particles are oppositely charged ions. The binding force present between these ions. So these ions are held with each other within a strong electrostatic force of attraction, which forms an ionic bond. Okay. So the binding force here we say that the electrostatic force of attraction present between the oppositely charged ions. Okay. So which forms an ionic bond. The ionic bond is present in ionic solids. Okay. So it is an ionic bond is formed. And since the third property about this ionic solids is, may say, the nature of these ionic solids. Must we know that the solids, they are hard in nature, but there are certain solids which are soft in nature. Okay. So the nature of these ionic solids, these solids are very hard. These are very hard because of the strong electrostatic force of attraction, or there is a strong force which binds the ions. So that's why these solids are very hard in nature. And the fourth property about its conductivity. And strength. Here the ionic solids, are bad conductor of electricity. So they does not conduct the electricity, they are bad conductor. So in saying the bad conductor and the good conductor, first let me explain why how we differentiate the compounds as conductor and bad conductors. The conductor is the one which carries the electricity. Again, bad conductor is the one which does not carry the electricity. Even though this solids contain some ions, okay, then also it is a bad conductor. Okay, it is because there is no mobile electrons are present in these solids. All the electrons are bonded with each other. So with a positive ion. So this is the negative ion is bonded with a positive ion. There is no free electrons or there is no free ions are available in a solid ionic crystal. So that's why it's in a bad conductors. And also these ionic solids, they become good conductor when they are dissolved in water. Okay. When they are dissolved in water, so this sodium chloride it's dissociate into ions as Na plus and Cl minus. Then we get some free ions which carries the electricity. So that's why they are good conductors in liquid state, so in a solution or in aqueous state, and these are also good conductors in molten state. As friends, the molten state means it is a liquid state of that ionic solids. When we heat that ionic solids, so it melts and converted into liquids. So in liquids, we have the free ions. So that's why in molten state they conduct the electricity, and in aqueous solution also they conduct the electricity. Okay. Therefore, the conductivity of this ionic solids are bad conductors, but they are good conductors in molten state and in aqueous solutions. So these are the four properties of the ionic solids. Okay. In comparative with that, I am comparing the same properties with the covalent solids and metallic solids. That is the constituent particles in covalent solids, binding force in covalent solids, nature and conductivity. And since another one, the fifth property for ionic solids only. So fifth property is these ionic solids are brittle in nature. Okay, brittle in nature means when we hit the ionic solids to one end with a certain hammer, so it breaks into two pieces. Okay, so that's why we call it as ionic solids are brittle in nature. Since the next one is the covalent solids. See, covalent solids, let me take example as diamond or graphite. So these are the covalent solids. So the first property of covalent solids is the constituent particles. So constituent particles in covalent solids are atoms. Atoms are the constituent particles, and the binding force is in covalent solids. The binding force, for example, in diamond, there is a bond is present between carbon to carbon. Okay. So therefore, the binding force present between the two carbon atoms is also carbon-carbon is bonded by sharing the electrons, which forms in a covalent bond. So the binding force here is the covalent bond. Here the atoms are bonded with each other by sharing the electrons, which forms a covalent bond. So therefore the binding force is a covalent bond. And the nature of these solids, the covalent solids, they are hard. Example, diamond is a very hard solid, or graphite is also a hard solid. So the nature of these solids is very hard, and the conductivity of the covalent solids, we know the conductivity once again based on the availability of the free ions. In diamonds there is no free electrons, or the ions are available. So therefore the covalent solids are bad conductors. But graphite is also an covalent solid. So in graphite there is a availability of one free electron. So except that graphite, the other covalent solids, they are bad conductor in nature. So there is the conductivity of the covalent solids. And since the next one is the metallic solids, the metallic solids, first let me go with the constituent particles. The constituent particles in metallic solids is positively charged metal ions and a mobile electrons are the constituent particles. Let me show you the arrangement of the particles in metallic solids. So this is the positively charged metal ions. These are surrounded by a mobile electrons. It just looks like the positively charged metal ions are dipped in a cloud of electrons or a sea of electrons. So therefore the constituent particles is in a positively charged metal ions. It is also called kernels, and a mobile electrons or a cloud of electrons or a sea of electrons. And the binding force is same what we observe in ionic solids. There is a electrostatic force of attraction between oppositely charged ions. There is the force of attraction between the positive and mobile electrons. Okay. So here is also the binding force is electrostatic force of attraction, which forms a metallic bond. So in ionic solids it forms an ionic bond. So here it forms a metallic bond. And since the next one is nature, we know the metallic solids, they are hard in nature. For example, copper, iron, all these metals they are hard in nature. And the conductivity is, the metallic solids, they are good conductors. So first we made the nature is hard, and the fourth one, they are good conductors, good conductor of electricity. So here the good conductor of electricity is because of the presence of these free electrons or the mobile electrons. So students, after this metallic solids, the next another one type of solids is molecular solids. Students, here molecular solids, they again classified into three types. One is polar molecular solids. Second one is non-polar molecular solids. The first, second one, and third one is hydrogen bonded molecular solids. So these are the three types of the molecular solids. Again, this classification, it is purely based on the binding force present between the molecules. So here in molecular solids, the constituent particles are, first let me write the constituent particles. In short, I am writing CP, constituent particles. So molecules itself is in a constituent particles in these molecular solids. But in polar molecular solids, the polar molecules are the constituent particles. For example, the polar molecules HCl, let me take this hydrogen chloride, is one of the polar molecular solids. We observe HCl in liquid state, but when we cool that HCl, it also forms solid. So that solid is one type of polar molecular solid. So this polar molecular solid, the polar molecules are the constituent particles. And the second property, we discuss the binding force. The binding force present between the molecules. Say students, in binding force, for example, say this is the one polar molecule, this is the another one polar molecule, say it's an A and B. It is having in a two poles, there is a positive and negative. Also AB, there is another one molecule, the negative and positive. So these two polar molecules are bonded with each other by a certain force of attraction. So that force of attraction is called weak van der Waals force of attraction. So this is one type of a weak van der Waals force of attraction which is present between the two polar molecules. So that force we call it as a dipole type of a force that we already learned in first year. The force of attraction present between the two dipole molecules, that is called as a dipole type of force. It is a one type of a weak van der Waals force which binds the two dipole molecules, and therefore the binding force here is in polar molecular solids is dipole type of force. And next is the third one is about the nature. The nature of these polar molecular solids, the polar molecular solids, they are soft in nature. Okay. They are soft. For example, just now I told the HCl. So HCl, even at room temperature, it is in liquid state. That means the weak van der Waals force are present between the molecules. So that's why these solids, they are soft in nature. Even at room temperature, they are in liquid state. Okay. And the last another one is about the conductivity. See, conductivity of these polar molecular solids, they are bad conductor of electricity because of there is no free mobile electrons are available in polar molecular solids. And since the next one is non-polar molecular solids, so here in non-polar molecular solids, the constituent particles are non-polar molecules. So first it is in a polar, and second one is in a non-polar molecules are the constituent particles. For example, solid oxygen or solid hydrogen or solid chlorine. So these are the non-polar molecular solids. So in which the constituent particles are non-polar molecules. And since the binding force present between the non-polar molecular solids is, there is again the weak van der Waals force. That force we call it a London force, or is a dispersive force which is present between the molecules. For example, think this is the one non-polar molecules. So say hydrogen, there is another one non-polar molecule, this is a hydrogen molecule, this is also a hydrogen molecule. So solid hydrogen molecule, when we imagine the solid hydrogen molecules, means there is a certain force which binds these H2 molecules. So that force is present between the two non-polar molecules. So that force we call it as a London force or dispersion force. Okay. So the force of attraction present between the non-polar molecules is London force. And the next one is the nature. These solids are also soft in nature, and conductivity. These are also bad conductors because of there is no free mobile electrons. And since the next one is the hydrogen bonded molecular solids. Hydrogen bonded molecular solids. Let's here. Let me begin with an example. For example, ice. So where the H2O molecules are bonded with each other by a force of attraction, that is called hydrogen bond. There is a force of attraction present between the hydrogen and a highly electronegative element of oxygen. So that bond we call as a hydrogen bond. Okay. So here in hydrogen bonded molecular solids, the hydrogen bond is present between the constituent particles. This is the one molecule and this is the another one molecule. So the hydrogen bond is present between the molecules. And the nature of these compounds is they are also soft and they are also bad conductors. Huh. So these solids are soft because at room temperature these are in liquid state, they are soft solids, and the conductivity of these electrons is in a bad conductor because of there is no free electrons are available to carry the electricity. So these are the few differences between the different types of the solids. There is a polar solids, non-polar molecular solids, and hydrogen bonded molecular solids.